Suppose from the surface of the earth there is a particle launched with a velocity v naught at an angle theta, right? Let's say from the point O. At a distance L from O, there is a smooth vertical wall. Pretty strong, will not fall after this impact. Ambuja cement. I'm after all not launching Khalli from here. And if someone had to launch Khalli, he would have had to use a rocket to launch Khalli. I mean, human beings can't launch Khalli. In any case, now, look. Now, if the wall was not there, under ideal conditions, this would land at some point P. This would land at some point P, right? Now, the range of this projectile, if the wall was not there, say if the wall was not there, it would take up this trajectory, complete parabolic trajectory, it would land at P. And the range of this projectile would be u squared sine 2 theta by g, and the time of flight would be 2u sine theta by g. Right? Say if this was the y direction and say this was the x direction. If you recall how we calculated this time of flight, we said, well, time of flight would be that state where y becomes 0 once again, right? We wrote the equation of motion in the y direction for the projectile. We said, well, y is u sine theta at any given instant of time t where the vertical displacement becomes some y, u sine theta into t minus half gt squared. That was y as a function of time t. When I spoke of the total time of flight, then it was the time t when y again became 0. Then that t was the total time of flight, isn't it? So y became 0 in a time t equal to 2u sine theta by g. Y again became 0. It started with y equal to 0, it again became 0 in a time equal to 2u sine theta by g. Total time of flight, right? That's how. Which means now in this calculation of total time of flight, what led to this total time of flight? What were the two things that enabled computation of total time of flight? One was the initial vertical velocity. Two was acceleration due to gravity. What was happening in the vertical direction, right? Now, if I changed the situation where the initial vertical velocity remained the same and g remained the same, but let's say I added wind in this direction. Suppose there was wind in this direction or there was wind in this direction, horizontal direction, not altering the initial vertical velocity, not altering g. Then what would be my equation of motion for the particle in the y direction? Same. The equation of motion in the y direction remains the same. U sine theta t minus half gt squared. Yes or no? right? So if there was a wind blowing in this direction at 200 meters per second or in this direction at 200 meters per second, the total time of flight, that means the time taken for y to become 0 will remain the same, right? Although it will not land at the same point P. If there was wind blowing in this direction, then it will land at some point P here. If there was wind blowing in this direction, it will land at some point P here, right? Its range will change, but the time it takes for y to become 0 will remain the same. Now, so if there are things happening which are not altering things in the vertical direction, that means they are not altering the initial vertical velocity and they are not altering g, then the time taken to land on the ground, no matter where it lands, will remain 2u sine theta by g. Suppose we had a situation where, say, initially it went to this point, suddenly at this point there was wind blowing in the opposite direction, right? And or somebody kicked it big time in this direction. Somebody kicked it big time in this direction and it started going here, then it came to this point. Then someone kicked it big time, it came to this point. Say, it came to this point, right? And so on and so forth, and eventually, let's say someone kicked it and it landed here. It started from O and landed at P. After these multiple kicks, horizontal multiple kicks, right? You know what I'm saying? Horizontal kicks, these are all horizontal kicks, no matter how many times. These horizontal kicks have neither changed the initial vertical velocity, nor have they changed the value of g. So then, no matter where it lands, y again becomes 0. So for this entire journey, no matter how zigzag it is, no matter how complicated the actual path is, the time taken to land on the ground once again will be 2u sine theta by g. Yes or no?
Yes, sir.
No?
So maximum height will also be the same. Maximum height
Will be the same. Yes, u squared sine squared theta by 2g. That will not change. You're right. The maximum height is initial vertical velocity squared divided by 2g is the maximum height. That will also not change. Perfect. So, if there are changes incorporated horizontally which are not affecting the initial vertical velocity and g, then the time taken to land on the ground, no matter where it lands on the ground, will continue to be 2u sine theta by g. Is the idea clear or not? Right? Now, once you understand this fact, this projectile path got prematurely terminated at this point, right? Now at this point, say Q, what happened? It had an initial velocity, it had a velocity horizontally, which was v naught cos theta. That never changed anyways. Just before hitting the wall, it had a velocity v naught cos theta horizontally. It had a vertical velocity some vy, which would be v naught sine theta minus gt, which would be v naught sine theta minus gt, right? So vy and v naught cos theta were its velocities. Now if it was a smooth wall, so this is just before impact, what does the impact do? Will the impact change vy? No, because it's a smooth wall. This belongs to friction. Whereas this is the line of impact. This is where collision occurs. This is the common normal direction. This is where collision is deemed fit, right? So then, this collision will not alter Vy, but will change V naught cos theta. So let's say its velocity in this direction, it rebounds with a velocity E times V naught cos theta. It rebounds with a velocity E times V naught cos theta. Right? So now, it has a velocity Vy, it has a velocity EV naught cos theta, and say, so it takes up a new projectile motion under the influence of this horizontal velocity and this vertical velocity. It will take to a new projectile path. Suppose the path it takes is like this, and it comes back to O. Suppose the path it takes is like this and it comes back to O, say, a hypothetical situation, say it comes back to O. Then, what's the time taken to go from O to Q and Q to O? Same time, 2u sine theta by g. If it didn't land at O but landed somewhere else, what would be the time taken to reach? 2u sine theta by g. Perfect. Now, so the time taken to go from O to Q and then back on the ground somewhere either at O or anywhere else is still going to be 2u sine theta by g. Now, because what is the wall doing? Is it changing the anything in the y direction? How did we calculate the total time? It's like it's kicking it like this softly, right? So if someone, that's what I told you. It's like kicking, and you kick it any number of times. Horizontal direction, right? Nothing is changing in the y direction. So the total time of flight will remain the same.
Sir, if it comes back to the same point, then the trajectory will be the same.
No. No. Why should the trajectory be the same? No. Not, of course not. The trajectory will certainly not be the same. Will certainly not be the same.
Sir, if it is a perfectly elastic collision,
Yes, then.
then it will just reverse the.
Yes. Yes. Yes, you're right. It'll just reverse the velocity, it'll become v naught cos theta. But it'll not go along this. It'll still go along this path, even if e is 1. It'll only come back to, suppose say it comes back to the same point. The entire idea is that it takes the same time to come back to the same point. Or any other point on the ground, the time taken will be 2u sine theta by g. Is that understood by all? So that must be time taken to go to Q and then come back to O. Okay. Tell me, what is the time taken to go from O to Q? Please tell me. What's the time taken to go from O to Q? What? Suppose this length is L. L by V naught cos theta here. Time taken to go from O to Q will be L by V naught cos theta. Right? Plus, what's the time taken to go from Q to O? Absolutely, L by EV naught cos theta. This then, if you require, you'll be able to compute E from these considerations. Is that okay?